All right, here we go. Last one of the week. 9-6A, 9-6A. Homework's in front of you. All right. So other angles, and yes, there's some weird things on the screen right here. It'll make sense when we get into the class. So notice it says other angles. We're going to conclude the chapter talking about segments and circles, but this one is going to be shapes and angles. All right, quick note. I mean, this is the scare tactic. You got to have a compass. You got to have a compass for next chapter. So we're a couple days away from being in that chapter. I would highly encourage you to get a quality compass, not more than, take $10 or something like that, if you haven't already gotten one. But you can't do any of the chapter 10 stuff without a good quality compass. A good quality compass is one that has it opens and closes, and it doesn't very easily change its position. The best kind have a little wheel on the inside. I'll show you a picture eventually here of what a good one looks like. And I'm not joking about failing the test. You can't take the test without a compass. The protractor is just used for a straight edge. You're not going to be drawing actual angles with it. You're going to be using your compass to make those angles. All right, so a nice, quick, easy class today to finish things up. But as always, it's more stuff and there's more formulas. But it's all pretty easy. All right, quick recall as always, or a quick relook at some of the material we've already got in this chapter. We started off with circles, and we started off with central angles, angle theta, and that's the angle that's formed when the vertex of the angle is at the center of the circle. We learned the relationship between the central angle and the arc it creates. Technically, it is a formula, but it's basically that the angle is equal to the arc. Now, we don't say congruent because they're two completely different things. One is an angle, one is an arc, but their values in terms of degrees are exactly the same. Last class, we were introduced to inscribed angles. We did get a formula for this one, and it turns out for inscribed angle, the angle is equal to half of the arc that it makes. So angle B there is equal to 1/2 of arc AC. You could also say this backwards. 2 angle B's make 1 arc AC. All right, so we got central angles and we got inscribed angles. Turns out that there's other angles, and that's what today's class is on. So let's see, the angle is at the center, the angle is on the circle. Well, there's 2 other positions. The angle could be somewhere inside the circle, not at the center, or the angle could be outside the circle, and those are going to be the 2 different types that we're going to talk about today. All right, so the vertex is inside the circle, but not necessarily at the center. In that case, if you extended the angle in the opposite direction, you get this X-looking shape. And if it's on the outside, it's going to look something like that. So those are the 2 basic shapes that we're going to be dealing with today. Okay, one at a time. We'll do the first one, the one with the X on the inside. Now, I will say what I'm about to show you would also apply if the vertex was actually at the center, but hey, if the vertex is at the center, then it's a central angle. We don't need a formula. It's not that this formula is that complicated, but it's certainly more complicated than the central angle is equal to the arc. So I call this spider, and maybe you see a resemblance. By the way, I didn't come up with this. A student a long time ago did, and I've went with it. So you got this basic shape right here. This is a really cool proof. I hope you enjoy it. All right, so there's the basic shape. I'm not claiming anything other than you have angle 1 and you have 2 chords, A, B, and C, D. They intersect somewhere inside this circle. It could be at the center, by the way. We're not claiming anything that it is obtuse, acute. We're just saying 2 chords intersecting inside a circle. I'm going to prove that angle 1 is equal to 1/2 of arc AC plus arc BD. All right, and here's how I'm going to do it. As always, I'm going to make triangles. So I'm going to construct a new chord, that one right there. Now you would think I'm going to make one to CB, but it turns out that's all I need is just that one chord AD to finish this out. By the way, next chapter, chapter 10, when it says this reason for this construction, the entire chapter 10 is on, well, how do you construct things? Like literally, how do you make a straight line between A and D? This is one of those duh ones. You take your straight edge and you connect the dots. So that was an easy construction. But other constructions construct an angle bisector, or construct a segment bisector, construct a perpendicular. Those are the ones that require a bunch of explanations and technique. And that's what chapter 10 is about. All right, back to our proof. Let's see, what am I going to try to prove? I'm trying to prove that angle 1 is 1/2 of arc AC plus arc BD. I got a triangle now, and more importantly, I'm going to pull up a little drawing right here. More importantly, if we take a look at, let's see, if I take a look at angle D, and if I take a look at what it goes to, we'll see angle D is an inscribed angle, and therefore it makes arc AC. Oh, that's interesting. And if I look at angle A, and if I do the same thing, I'll do it slightly above. If I see what it makes, it actually makes arc DB. And why is that important? Because we have formulas for inscribed angles. So what are the formulas? Let's see, the inscribed angle, angle 1, if I label angle 2 and angle 3 there, I noticed for the triangle, we have that exterior angle triangle theorem that says the exterior angle 1 is equal to the sum of the two remote interior angles. That would be angle 2 plus angle 3. And the thing that I just drew on the screen right there is where we're going to make our money. So angle D, or basically angle 2 there, well, I got a formula for angle 2. Angle 2 would be 1/2 of arc AC, and angle 3, the red part there, that would be equal to 1/2 of arc BD. And that was that theorem 9.7 for inscribed angle that we did last class. Cool. Now, hopefully you see it. I'm going to do a substitution into that equation right there. The one below it says if I see angle 2, I can write 1/2 arc A, or the measure of arc AC. And if I see angle 3, I can write 1/2 arc BDs. So that's my substitution. I'm going to substitute for angle 2 and angle 3, the arc portion. And that's what I just did. Yay for us, because hopefully you see it. All I got to do now is factor out 1/2. And I'm got my equation. All right. So what do I have? I got to clear all that stuff out. If this is the shape, now you see where angle 1 is. Angle 1 could be any one of those 4 angles on the inside. But what it does is it creates a formula. And the formula, if this is angle 1, it's going to talk about its relationship to the arcs that are across from it. So arc AC and arc BD. And what is that relationship? Angle 1 is 1/2. Angle 1 is 1/2 of those two arcs right there. All right, so that's what it states. Now, I do want to point out, I'll do this one in blue, that if angle 2 is, I'm not drawing anything. Let me go back. Angle 2, if this was angle 2 right here, why are you not drawing it for me? Draw, darn you. Oh, technology, I love it. All right, let me try this one last time. Angle 2, are you going to work for me? Yes, there you go. Angle 2 would be 1/2 of arc AD plus arc CB. So that's what you would get if for angle 2. All right, so don't get hung up on the names of them, arcs and the angles, because the angle could be any one of those 4 angles on the inside, but it would refer to the arcs that are across from adjacent, up and down if it was up and down, left and right if it was left and right. Hopefully that made sense. There are words to this theorem right here. You see them, you saw them twice when I was messing around there. And those are the words. I find that the picture and the blue and the yellow there makes way more sense than the words, but the words are true. The measure of an angle formed by 2 chords, the 2 chords are A, B, and C, D, that intersect in a circle. The two chords, A, B, and C, D, intersect in the circle, is equal to 1/2 of the sum of the measures of the intercepted arcs. Great, and that all makes sense. I'm going to go with the picture and what's written there in yellow. All right, so that's theorem 9.9. So what is it going to look like? It's going to look something like this tonight for homework. They're going to give you a circle. You're going to see the shape where you've got an X in the center of a circle, and you're going to have a series of angles. So let's see. Well, we can do this in any order we want, but it makes sense to start with 1 because, well, 1 comes before 4. How about that? Let's see. So angle 1. So angle 1, let's see. Angle 1, I'm going to do some blue, is right here. So it would be equal to this arc, the one that's across from it, and the other one that's across from it, added together, divided by 2. All right, so that angle is equal to those 2 arcs, added together, divided by 2. I forgot that I actually had this annotated. Okay, so what are those numbers? 85 and 75? 85 and 75 are 160, and half of 160 is 80 degrees. All right, so angle one is down. There's lots of ways of looking at this. For instance, you might want to do angle two. Nothing wrong with angle two, but if you look at, we got an X, right? Remember, whenever we have an X, that's vertical angles. So angle three is vertical to one. So yes, you could use the formula again, or simply rely on the fact that you have vertical angles, 1 and 3. So therefore, 3 must also be 80 degrees. All right, two ways to do 2 and 4. You could use the formula, I'll do it right here, or you could see the relationship between 3 and 2 is they form a straight angle, 180 degrees. So 180 minus 80 is 100. So let's say you don't remember that and you're going to just go with the formula. So let's see, there's angle 2. It's got an X, so therefore it's equal to 1/2 of the two arcs that are across from it. So if I'm looking at angle 2, the ones that are crossed would be up and down. So 95 and 105. So add 95 and 105, that's, 200, and half of 200 is 100. And like I said, you could have easily gotten that from angle 3 as well, too, without using that formula. Remember, a straight line is 180 degrees. If angle 3 is 80, then angle 2 must be 100. All right, and no, I'm not going to use the formula to get 4 because 2 and 4 are vertical, so that means that 4 is 100 as well, too. There you go. All right, that's it for the X. How about for the other shape? And yes, somebody thought it looked like a ninja when they saw this shape. So the vertex is on the outside. Okay, you got to stretch your imagination to see that shape, but it's like where the face and the mask come together. It makes that kind of look. At least that's what I was told. All right, so similar proof. Different shape, obviously. Ooh, look what the formula says. Instead of adding the two arcs, I'm going to be subtracting the two arcs. So look at angle 1, and then look at the two arcs that are across from it. The farthest one, AC, if you subtract from that arc BD and then take half, apparently you get to angle 1. Well, let's prove that first. All right, same drill. I'm going to make triangles, right? So I'm going to connect from C to B. And I'm going to do some labeling here. So that angle there, C, I'm going to call angle 2. Angle P, for some reason, now I'm going to call angle 1. And angle ABC, I'm going to call 3. All right. Same drill as the previous time. Look at angle 3. Angle 3 is on the outside of the triangle. So 3 is equal to 1 plus 2. Right? A little bit different this time. I'm going to do a little bit of algebra with that equation. Let's see, I'm going to solve on the side that has the angle 1. So in other words, I'm going to subtract angle 2 from both sides. So that would give me angle 1 is equal to 3 minus 2 for angles. Okay, so a little bit of exterior angle triangle, exterior angle of a triangle theorem, and a little bit of algebra manipulation. The rest of the proof is done the same way. Let's see, let me make sure I highlight this. Okay, so if you look at angles, yeah, I'm in blue. Angle 3 right here, well, the arc that angle 3 makes is, in fact, arc AC. So angle 3 would be equal to 1/2 of arc C, and then, I don't know, green, maybe? And then look at angle C, and angle C would be equal to 1/2 of arc BD. There's some horrible colors there, but hopefully you get that idea. Okay. All right, so that's what I just said right there. Now, I called it angle 3 and angle 2. That's the ones that I circled. Why did I circle angle C? Because I forgot to circle angle 2, but you get the idea there. So 3 or C and 2 are exactly the same. Should have called it angle 2. Okay, so now what? The substitution, same thing as last time, but I'm going to substitute in the one that I just made in red right there. Why? Because look at where we're going at the end of the proof. We're trying to say the measure of angle 1, something about it. So substitute for angle 3 and angle 2, the line below it. So let's see, 3 is 1/2 AC, 2 is 1/2 of BD. So that's my substitution. And then the same thing as the previous one. I'm just going to factor out a half and I'm done. Okay. Let me clear out that mess right there, and we'll write down the theorem. All right, so this is theorem 910. Don't get hung up too much on the lettering and the labeling, because they could name this anything they want. But if this is the basic shape you have, if you have an exterior angle, that's angle 1 there, it's going to be equal to two arcs subtracted. Now, what's the order? The order will always be the farthest arc, that's AC, subtract, and then from that, we're going to subtract the closest arc to the outside angle, exterior angle, angle 1. That would be arc BD. So some people think about this as the biggest arc minus the smallest arc. I like that. Other people think about it as the farthest arc subtracted, the farthest arcs minus the closest arc. Some people think of it as the big arc minus the small arc. Any one of those idea works. If you write down what's there in yellow, obviously it only applies to this picture where everything's labeled accordingly, and we all know that's not going to happen for homework. So I generally think about it, this is farthest minus closest, but a lot of kids think about it as biggest minus smallest. And by the way, if you have an exterior angle like that, then the farthest arc will always be the biggest. It's never going to be the closest minus the farthest. It's always going to be the farthest minus the close, because the farthest is going to be the largest one, because it's an angle. All right, there are the words. The measure of an angle formed by two secants. Notice that AP and CP are secants. Two tangents or a secant and a tangent. Oh, so this applies to more than just one. From a point outside a circle is equal to 1/2 of the difference of the measures of the intercepted arcs. Notice they don't say anything about farthest, closest, biggest, smallest. They just the difference of the two. So obviously in geometry, we had to have a positive value. So you would always be subtracting them in the order of the largest number minus the smallest number. All right, cool. So it turns out that this comes in a couple different flavors, 3 of them to be precise. When the vertex is on the outside, you could have 2 secants, right? 3 flavors, 2 secants. So it'd be y, 1/2 of y minus x. It could be a secant and a tangent. It's still gonna be 1/2 of y minus x. Or you could have 2 tangents. It's still gonna be 1/2 of y minus x. So I mean, the but here is that it's still gonna be the same darn formula. So no big deal, right? In fact, you don't even have to worry about whether it's secants or tangents here. Quick examples right here. Let's see, the first one is 2 secants. Still doesn't match. It's farthest minus closest, and then take a half. So 85 minus 15. Let's see, 85 minus 15 is 70, and half of 70 is 35. 2 tangents, that's the second one there. It's going to be farthest minus closest. So 215 minus 90 is 130, or I'm sorry, is 135. Sorry, yeah, that's right. 135, 125. Can't do math today. 125. There we go. Yeah, 125. 62 plus 62 is 125. Okay, or if it's a secant and a tangent, that's the bottom one. Oh, I can do this one. 130 minus 60 is 70. Half of 70 is 35. Okay. And believe it or not, that's it. All right, what's homework going to look like? It's going to look like something like this. Questions 1 and 3 are your first shape. You get an X in the center of the circle. It's the opposite angles added together divided by 2. So on question number 1, 40 plus 30 is 70. Half of 70 is 35. Look at question number 3. It's asking for angle 3. So it's 135 plus 140. So that's 275. And take half of 275. Now look at questions 2, 4, 5, and 6. You have an exterior angle. 2 is 2 secants. 4 is 2 tangents. 5 is a secant and a tangent, and so is 6, a secant and a tangent. It doesn't matter. It's farthest minus closest. So look on number 2 and then take half. So it's 120 minus 40, which is 80. Half of 80 is 40. It's a coincidence that there's a 40 right next to it, and the answer is 40. Question number 4. Okay, finally, here's one that requires a little bit of thought to it. So let's see. What's the problem with number 4? Problem number 4 is that this arc isn't labeled. Well, we know that it's 2 tangents, and we know from here all the way around is 260, which would leave 100 for this part right here. So 260 minus 100 is 160. Half of 160 is 80 degrees. How about number 5? Anything tricky here? No. 170 minus 80, take half. How about number 6? Yeah, 6 is a little bit tricky once again. Notice this part isn't labeled, but this part is, and there's 360 degrees in a circle. So from here to here is 160. From here to here is 120. 160 plus 120 is 280. So that leaves, I sure like their 80s this today. So that leaves 80 degrees for this arc right here. So let's see, 160 minus 80. Remember, we add for the Spider-Man one. For the Ninja one, we subtract. 160 minus 80 is 80. Half of 80 is 40. So they love their 80s and their 40s today. All right, pretty straightforward class. I said it would be easy. They can throw some variables in here occasionally, and no big deal. Let's do number 9 and call it a day here. So let's see, what's number 9? That one looks complicated. So it's the Ninja one, so it's farthest minus closest. The farthest one right here is labeled 360 minus x. So 360 minus x. And from that, we're supposed to subtract the closest, and the closest is x, so minus another x, and that is going to be equal, after we take a half of it, that's going to be equal to the angle. And notice the angle is listed as 58. All right, you've played this trick before. Get rid of the 2 first, so multiply both sides by 2. Let's see, 2 times 58 is 116. And I'm going to try to do 2 steps at once here. A minus x and a minus x is minus 2x. So let's see, 360 minus 2x. We are going to get a negative for the next step, but it's okay. Don't panic. Remember, it's only panic time if you get for a final answer is negative. All right, so what are we going to do? We're going to subtract 360 from both sides. So let's see, 116 minus 360 is negative 244. So we get negative 2x, and you can see why we're going to get a positive answer here, is equal to negative 244. And then divide both sides, not by 2, but by negative 2. And we get to, and remember, it was just asking us to solve for x right here. So you divide everything by 2, and that would be 122. And that would be in degrees. So anywhere you see an x, you got 122 degrees. And there you go. And that will do it for today. So good luck with your homework as always. Oh, I do need to show you this. All right, take a deep breath. Don't panic. This is going to be a scary picture. Remember, questions 1 through 10 on any homework exercise are always the easiest one. Turns out this one is easy. It sure doesn't look easy. This is 1 through 10. There are 10 questions right here, and there are no numbers. There's only labels. Right. They do give you, I think, 3 pieces of information. And I don't have them listed right here. If you do have problems, I'll just say, here's my hints. Declutter the picture. I do believe they give you BC. I think they say BC is equal to 90 degrees. I think that's one of the things they give you there. Therefore, angle 1, and they give you that O is the center. Therefore, angle 1 is 90, and you can go from there type thing. But take it one little piece at a time. You don't necessarily have to do them in order. If you do run into a problem, I'll give you a full explanation of it. All right, so good luck on that one. That usually causes kids problems. Here's your homework once again. And with that, we'll end it. Good luck.